look in this lesson at surface area, specifically of prisms, but in general, what is surface area? That's when you're, well, as the name implies, you're going to cover the surfaces of a prism or some other figure, and you want to know what that area is. Like if you're going to wrap it in paper or paint the walls or something, you need to know how much paint or how much paper you need to cover it. That's surface area. So as we do it with prisms, we want to start off with just a recap of the vocab that we learned. A prism, again, is a three-dimensional figure, and it always has these two congruent bases. They're both congruent and parallel. So just as a quick example, if we look at this rectangular prism, I see the rectangle as a base, and I also see a matching base right up here. There are two bases. They're congruent and parallel. Now in this oblique triangular prism, the obliqueness of it means that it's got that slant to it, but still these two triangles as bases are exactly the same shape and size, and they do run parallel to each other. Now the lateral faces of all prisms are parallelograms. Most of the time those parallelograms are rectangles, but in, again, the oblique prism, they will be those slanted parallelograms. And finally, and something really important to note, the height of the prism is the distance between those two bases. For most prisms, it's going to be one of the edges, but on oblique prisms, it will be measured on the outside so that they have that distance between those two bases. Now, all prisms are classified by the shape of their bases. So we will look at this one as a triangular prism. The base of this one is a rectangle. We call it a rectangular prism. Pentagonal base would call a pentagonal prism. Now let's take a look at a way we can derive the formula for finding the surface area. The strategy is generally this. You may have seen something like this in a previous class. This is what we call a net. And a net is simply a flat pattern for a three-dimensional figure. So think about this: if it was all folded up and taped together, then it would form this type of a prism here. Let's look at our prism and let's identify the different parts of it. What do we call this distance here between the two bases? That's the height of the prism. Now where do we find that in our net? That would be the length of any of these vertical lines running across. So let me just put it right here. It's the same measure. And the other thing that's really important about a prism is its base. So let me give you this whole base area right here, this whole rectangle, and of course there's a matching one that we can't see up here. Where does that show up in our net? Well, that's this rectangle. And this second rectangle is the one we can't see. Those are our two bases. So if we want to find the area, we would need to take these two bases and add this big rectangle. Well, what does that big rectangle represent back on our prism? That is the walls of the prism. So the walls of the prism, again, those are called the lateral faces. And there are four of them, but if we open it up, it's one big rectangle. I want you to take a look. If you can figure out the area of this big rectangle, then you've got the area of all the lateral faces together. And that's not too hard to do. We just take the length of it times the width of it. Well, we already know the width of it is the height of the prism, but how long is it? What is represented by all four of these little pieces back on our prism? That would simply be just this segment, and this segment, and this segment, and this one all added together. In other words, that would be the perimeter of the base. So this is the perimeter of the base here. So here's what it boils down to. The lateral faces, the area of those lateral faces called the lateral area, let me change this to lateral area, is simply the perimeter of the base multiplied by the height of the prism. So that would be the perimeter of the base P times the height of the prism. And then if you want to get the total surface area, and we'll just use SA to represent that, then it would be the lateral area, which we use a capital L for that, plus two base areas, because again, look at your picture, there's two areas to add in for the bases. And that works for all prisms. Let's see how it works with this net. This length right here from one base over to the other would be the height of our prism, and it would be represented right here along this edge. The distance around the whole hexagon, whoa, there we go, that distance there would be the perimeter, and when we unfold it, that's going to be this entire length here, all six of them together. So the lateral area, one more time, the lateral area is just the perimeter multiplied by the height to get that full rectangle. And then if you want the total surface area, you're going to need to add these two bases in. Well, they show up here and here. So the total surface area is just the walls, which we already figured out, plus the two bases. So to summarize it in your formula box, the lateral area, you would take the perimeter around the base and times that by the height. Let's show where that is. The perimeter around the base is all the sides added together. And then the height would be the distance out to the other base. And then if you want the total surface area, you're going to take the lateral area you figured out and you're going to add in two base areas, because every prism has two bases. So add that base and add the one in the back. Before we do this first example, I want to emphasize with these problems, guys, there's a lot of calculations that are going to go on. There are many, many steps to figuring out these problems. And so you want to be very, very organized. And I've laid out kind of a strategy of things that you should do. Let's read through this really quickly and then let's apply it. So the first thing you have to do is identify the solid that you're using by its base, and then also record the height of it. Second, you need to identify which formula you need. Are you doing lateral area? Are you doing surface area? Even volume is going to come up later. Then the biggest work comes in step 3. This is the most work you're going to have to do. Find the base area and the perimeter. And once you have that, you're going to be able to substitute those values right into the formula. So let's go through the strategy with this example. We're going to find the lateral area and the surface area, but first we have to identify what this is. Look at the base of it. Here's the base. It's sitting in the front rather than on the bottom. What is that? That's a trapezoid, so we're going to call this trapezoidal. And because it has a twin in the back, it's a trapezoidal prism. Now before we finish this, we're going to want to make sure to identify what the height of that prism is. So how far is it from one base back to the other base? We're going to pull it off right here, and I'm going to make a note that the height of this prism is 12. That will come in handy a little later. Okay, so that's step 1. We've identified the solid by its base and we've recorded its height. Now we go to step 2 and identify the needed formulas. Those come from the question. They ask us to find lateral area and surface area. So we're going to use, on our prism, we're going to use the lateral area of a prism, which we've just discovered is the perimeter times the height. Leave some space there. In fact, let's put some blanks because we're going to fill these blanks in a minute. And then they also want to know the surface area. And the surface area is the lateral area plus 2 base areas from our formulas. Now we're on step 3, and we have to figure out the base area and the perimeter. So we have a trapezoid, and we need to get its base area. We're going to call this big B for base area. And in a trapezoid, that formula is 1/2 of the 2 bases of the trapezoid, of course multiplied by the height of the trapezoid. So to our trapezoid we look. What are the bases of our trapezoid? As I'm looking, I see one at the bottom is 20, one at the top is 10, so 10 and 20 in there. And then the height of our trapezoid is the distance between those two, which is the 8 centimeters. So making those substitutions, and then as we multiply this, is 120. And that's our base area. We also have to figure out the perimeter of the base. Okay, we got the base area, but we're not done. We got to get the perimeter. So let's add up all the sides of it. Starting from the 20 on the bottom and working around, I see 20, I see 9, 10 at the top, and then along the last side it's 10 down that last side. So a total here looks like 49 is our total on the perimeter. All right, that's step 3. You see, that was a lot of work. Now that we've done step 3 so well, we're ready to go to step 4 and be done. We're going to just substitute our values into the formulas. All right, so into our formulas for prism, we have the lateral area, and that's the perimeter. We can pull that from our workout down here. We got 49. And then the height. Now here's where it was so important. The height of the prism is the 12 that we recorded way back. A lot of times you go back and you can't remember what that height was by the time you get to this point in the problem. So you have it there. And so let's just calculate that. And I'm getting 588. 588, and let's put the unit on there. Square centimeters. This is still area. Okay, now for surface area, according to our formula, we're going to just take that lateral area. We just got it. It's 588. Bring it down. Plus 2 base areas. Now, where do we get the base area? Well, we did all the work right here. It's way back here. That base area is 120. It's important to be organized so you can remember by the time you get to the next step where you were. All right, so if we just add those together, we get 828 square centimeters for the total surface area. Lots of steps. Just be really organized and you'll be all right, step by step. Okay, so same thing. We're going to do the lateral area and the surface area of the prism. But no, they also want here an exact answer and then an approximation to the nearest tenth. So we're going to be doing a little bit of calculation as well. Let's go for the first step, and that is to identify what this is. Look at its base. You see the 6 sides? That's a hexagon. So this is a hexagonal prism. And how tall is it? Before we're done, let's note that the height of this prism is 16. Do you see that? That's, again, the distance between the 2 hexagons. Okay, so all the work I'm going to do here, now I'm on step 2. What formulas do I need? Well, the question wants lateral area, so I'm going to write that one down. Lateral area is perimeter times height, and we can plug in some numbers in just a second. It also wants surface area, so that's going to be lateral area plus the 2 base areas that I get. All right, so we'll have places to plug those in. Let me just get ready for them. Now for step 3, we're going to analyze this hexagonal base that we've got. So it's a hexagon. We need to figure out both the perimeter and the area of it. Let's get the base area by doing half of the perimeter times the apothem. I just said it wrong. So we'll get ready to fill in a few blanks. And then before we're done, we also need the perimeter of this hexagon. In fact, we need the perimeter to do the area. So let's go ahead and do that perimeter right off. We've got 6 sides, and if we look at our diagram, it looks like they're all 4 meters long. So 6 times 4 meters each. 24 meters is the perimeter. I'm going to put 24 up here and for my base area too. Now for the apothem. The apothem is from this center point straight down. And we've seen this before. We're going to have to make that little triangle. What do you remember about that little triangle? I remember it's a 30, 60, 90 triangle. And so this is that 30-degree angle that we've seen before. And this side has been chopped up into a 2-meter side. So if I want to go back here, this is going to be 2 radical 3. All right, so our apothem is 2 radical 3. Now as we go to calculate that, let's just take half of 2 and cancel those right out. So it looks like our base area is 24 radical 3. All right, that's a lot of work. That's all the prep we've done from the last chapters. Let's go now to our formulas. What did we get for perimeter back there? 24. And the height of the prism right there is 16. All right, let's calculate that. 24 times 16 is 384. So our lateral area, or the walls, is, not centimeters, 384 square meters. There's one answer. Surface area, all the surfaces. Let's keep the walls. We got the walls of 384 and 2 base areas. Looking back, it looks like our base area was 24 radical 3. Stick it in there. So in the base area, we have 2 of those. So that would just be 48 radical 3. When you add 384 and 48 radical 3, the only way to keep it exact is to just keep those separate so we don't go into decimal. And they wanted the exact answer, so there's one of my answers. And then I can go ahead and convert that into a decimal with my calculator. So getting all of that in there, it's about 467.1 it looks like. So 467.1, about square, I keep wanting to do centimeters, square meters. That's the rounded number. Okay, moral of the story, be super organized. Take it through those steps and you should be able to go step by step through this and have a good time.